We are good. All right, welcome. This particular session is on technology applications for agricultural plastic recycling. We've got three presenters. Our first presenter is Lennart Bendfeldt. He's a solutions manager for eFactor 3. And his presentation is going to be on optimizing agricultural plastic recycling, a comprehensive approach. So with that, I'm turning it right over to you, sir.
All right. Afternoon. Hope everyone's doing well and ready for a riveting session. As Gene said, I'm here to talk about some agricultural plastics recycling technology. Ben Andros was so kind as to dub us the advanced mechanical recycler. So I'm going to take that, I'm going to run with it, and you can't take it away from me. Anyway, so as Gene said, Solutions Manager eFactor 3. As a quick background, my dad's sitting back there. He founded the company in 2008. And what we are is an engineering and machinery distribution company. So we don't actually manufacture the machinery ourselves, but we have 9 partners scattered across Europe. Most of those we've been working with for the better part of a decade, if not longer. And when a client comes to us with a certain material that they need to process and a spec that they need to achieve, our engineers, the engineers of our manufacturers, and our clients will work together to prove out a process, and then we deliver that turnkey package to those clients. Over the last 16 years, we actually celebrated 16 years last week officially. We've delivered several dozen recycling lines in the waste and plastics industries across North America, so that includes Canada and the entire continental US. All right, let's jump into this. Who we are, I just gave you that, so I should have been on that slide, but that's okay. I'll forgive myself. We're located in Charlotte, North Carolina, and as it says up there, and as I kind of mentioned, we're a one-stop shop. So a lot of places you can buy a piece of machinery, but once you have that piece of machinery, where are you going to go for your service? Where are you going to go for your spare parts? Well, we have wrapped all that into one shop. So we've got 5 full-time service guys that work in our service team, and we've got about $2 million worth of spare parts on our shelves in Charlotte. And that's not just to pat ourselves on the back the way I say that, but it's also to make the point that you can't have a reliable system of machinery if you don't have a way to support it in the US, right? European machinery can look awesome, but it's not if, it's when that machinery goes down, how are you going to get back up? And that's the solution that we plan to provide and have been providing for the last 16 years. This is a whole beard and 25 pounds ago, but that is me up there. I should probably need to change that out. I started with my dad in 2016. Since then, I've been working with him to put together projects across, again, the plastics and waste processing worlds. And my role as solutions manager is sales, but as someone that seems to have some technical knowledge in the machinery that we sell, I work between the marketing team, the sales team, and our vendors to make sure that those 3 worlds are actually communicating. As you guys may know, sales and marketing are different roles, and one can't really dictate the other, but they also have to know who is doing what. The left hand needs to know what the right hand is doing, otherwise you have a disjointed mess. So, jumping into ag plastics specifically, we say ag plastics, and some people have touched on that, but that's a wide variety of different materials. One processing line that can do drip tape may not necessarily be 100% built to do mulch film. We have to make sure that we specify the material and the incoming material stream as best as we can, so that we actually provide a solution that is tailored to that. And of course, also important is the output spec. It's always nice to ship things overseas, as we've talked about earlier today, but if we want to start selling things more domestically, we need to figure out a way that we can achieve a tight spec on those output materials. If somebody's injection molding a part or trying to make blown film with some percentage of PCR, they need to be able to rely on your system to deliver that continuously standard stream of material. As has been touched on a little bit, ag film is a material that nobody wants to touch, and it sucks. It really does. It's filled with moisture. It's filled with dirt. There's, as much as people like to promise, oh, we have no metals, we have no pieces of rock, that's a lie. If you process this material, you're going to get big, unshreddable, unprocessable pieces of material. And that is kind of the first thing that we need to address on the processing line. I've heard people talk about granulating ag film as soon as it comes into your recycling facility. That is, in our experience over the last 16 years, not an effective way to deal with this material, simply because you have so many unshreddables in there. If you go into a granulator or a fine shredder that uses a shearing action to cut that material up, the sand in there is going to wear the hell out of your machine, and then any stones, any pieces of metal that get in there are going to destroy your blades. So how do we overcome that initial challenge? And that is part of this preparation of the material. The first step is going to be size reduction. As Theron talked about with his guillotine, we provide a solution out of Denmark called M&J Pre-Shredder P250. There's also a larger model and some smaller models depending on the size of the bales and the throughput that you're looking to achieve. But the key difference between this and standard single shaft shredders or granulators is that we do not have a rotating knife against a bed knife shearing action going on. These two independently driven shafts more pull the material apart rather than shearing it. It works on the principle of high torque and low RPMs. And so what that means is when we get a rock in there, when we get a piece of metal in there, we're not going to destroy our cutters. We're not going to get downtime. We're not going to hurt our machine. So you get a bale in, you get those wonderful rolls in. It's simply going to pull that material apart into 12 to 14-inch pieces and loosen it up enough such that we can start to get out some of those rocks, some of those pieces of metal, some of that dirt, and some of that moisture. These pieces of machinery, they come in both mobile and stationary shredders. We have a fleet of 6 of those mobile units, as well as landfills, plastics recyclers, employing them all across the country. I think in the last 15 years or so, we've put about 80 of these units in the field, and they are probably the most robust piece of shredding equipment that you can find in this field. And that kind of gives us the flexibility to bring these to demo sites, to trial these out for clients, and to be everywhere that a client needs us to be. And then once that client has proven that this technology out, then we also have stationary options for them to put in permanent systems. The next thing would be some kind of magnet system so that we can get out those metals. Again, everyone's going to promise you, oh, our material stream doesn't have metals in it. And nobody is hopefully purposefully putting metal in there, but it's going to happen. It's not, again, it's not if, it's when. And you need to prepare for those eventualities lest you want to, risk just hurting or destroying your downstream equipment. And the next step for us, and again, over the last 16 years, we've done a wide variety of trials, spent tens of thousands of dollars of our own money in proving out this technology. And the next logical step for us has been screening this material. Again, I saw that the previous presenter is using a trommel to screen it out, and that is a great option. Whether that's a flip flow screen, some kind of vibratory screen, a trommel, or in our case, the EcoStar HyperDisc screening system, that is the next step, because now you've got a large piece of shredded agricultural plastic. It's got a lot of dirt on it. It's got little rocks on it. It's got pieces of wood on it, most likely. And you need to be able to get the majority of that out before you ever think about washing, unless you want to end up with mud in your washing line. That doesn't make any sense. And what makes the EcoStar a little bit unique, number one, they're located outside of Venice, Italy, so never been a better time to visit a manufacturer. But it's like a star screen, except the stars are hexagonal discs. And what that means is when these shafts are rotating, those edges of those hexagons do a great job of agitating the material. If you were to just place a piece of agricultural film with dirt on it on a screen, you might get a little bit of it knocked off. But with this very aggressive agitation that the EcoStar has, we found that you can remove a lot more of that dirt on the front end before getting into the further downstream equipment. And the more you get out downstream, as these gentlemen that do extrusion filters will tell you, the better that your downstream equipment is going to work. Now, even once we screen, we will still probably have some heavy contaminants in there. Whether that's rocks or heavy vegetation, root balls, we have to screen at a certain size. Sometimes, the loose dirt and soil will fall through, but sometimes we still get larger pieces of contamination going through. This is where the wind sifter comes in. Now, our supplier, Westeria, out of Germany, they produce this piece of machinery. It's widely used in the RDF production world, which is waste to energy. And they have a similar problem where they have super dirty material that nobody wants to work with. So the principle is essentially let's see here if this works. Okay. We have an acceleration conveyor here with an air knife. And when that material goes over the air knife, the heavy material will hit the separation drum and fall down. And the light material will go on to the light material chamber. Now, if you put agricultural plastic through here and you get a root ball, you get a piece of metal, you get whatever large contaminant made through the screen is going to come out here because size is one thing, but you can't lie about density, right? Density is simply a physical characteristic of the material. And here is just a quick example of something that we have put together in the past. We start out with shredding, then we go into a magnet, a screen, and then dry washing piece of machinery. And I'll get into that here in a second. Now, before we can go into downstream equipment, we've done a good job with the screen, with the wind sifter, with the pre-shredding to get out a lot of the unshreddable pieces of metal, pieces of rock that are going to destroy your granulator, that are going to hurt your single shaft shredder. But now we can go into that single shaft shredder and get a homogeneous output that is going to be even easier to process. If you have varying sizes in your pieces of material, it's going to be more difficult for your downstream equipment to process that. So we shred it down to maybe 1.5 or 2 inches, and we have a homogeneous output to go into our downstream equipment. That could be either single shaft fine shredder or a granulator, as you see in this. And then there are a couple options depending on what your material goes into, and that's why defining the scope of what you and what your end users are going to be doing with the material is extremely important. If you're going into pyrolysis or advanced chemical recycling process, you most likely have higher tolerances for dirt than a mechanical recycler is going to have. And knowing that spec at the end is going to make it easier for you to decide on, can we get away with dry washing or do we need to go to a full wet wash? Does that full wet wash, does that need to go all the way to a hot wash, or can we get away with a cold wash? The DRD is from Moss. It's a company in Austria that we've worked with for the last 12 years. And the material comes in through air pressure down here. And simply this impeller down here creates turbulent air so that the material is essentially being slung around in this chamber. That chamber has a screen on the outside, and we're continuously pulling air out of it. And what happens there is that material, as it's being slung around in this centrifuge, we have hot air being pumped into it, so it's being dried off continuously. And as soon as that dirt dries off, instead of trying to scrape it off like mud, we can actually just crumble it off like loose dirt. And that is the action that we get here in the DRD. And we can get a suitably a clean piece of material for pyrolysis just with this, without having to go into a friction washer. A little bit of the concerns that come up with ag film, like UV degradation, are actually quite minimized in this piece of machinery because we don't have the action of a piece of metal rubbing the ag film against the screen. It's simply air flinging it around against itself and the screen. So we actually create much less fines than a traditional friction wet washing line. And this is kind of what a complete system from Moss would look like for dry cleaning. You know, we've got, I think, 70 of these across the world that Moss has put in, including here in the US. And that includes dust collection, the actual DRD chambers themselves, which are outlined here, and the buffer silo and material handling equipment. Again, what are the advantages? The biggest one is you don't have to deal with water. If anybody here has ever done wet washing, you know the biggest pain in the butt is dealing with the water that comes off of it, especially here in California where you've had strict, for a good reason, but you do have strict water regulations. And what do you do with that water? Well, what if I told you that depending on the spec that you need to achieve, you don't actually have to wet wash it or deal with these water permits? Also, heating up water is extremely expensive energy-wise. We can even have a much more economical system with this because we're saving money on heating up water and paying for the water itself. And then there's just the simplicity of operation. Again, you know, I feel like I've said the word water 15 times in the last 10 seconds, but it's a lot easier to deal with when you don't have to deal with water. Here's just some examples of input and output. Now we have these samples in our offices. We have plenty of videos on our YouTube. You can actually see with your eyes just how much cleaner we can get the material through just one pass. Here's another good example. And here on the right side, you can see this comparison. We put the material into water, and you can see on the left side, that's an extremely cloudy water. On the right side, that's after only dry cleaning. We get a much clearer glass here to show the amount of dirt that we've actually removed. Here is another system that we work with in Germany called Plato. They produce what's called another dry cleaning system, but it uses the traditional friction. So we do also bring up that option. And again, it depends on the spec that you need to go to. There's no one size fits all in the recycling world, and especially not with ag film. And if anybody tells you that their system can do it all, they're lying. This is kind of what the inside of that piece of machinery looks like. You know, we've got these friction paddles on the inside that you can see in the top left, and on the outside there's simply a screen that contamination passes through. This can be laid out with dry cleaning, where we're just doing a dry friction wash. There's a crossover cleaning where we simply mist the material, make it just a little wet to make it easier to get all that material off. And then there's also options for full wet washing. And here's just a good example. This is HDPE with a lot of labels on it. So used very effectively in things like stretch film processing where you have a lot of distribution stickers on there. And then this is flower pots. This is hips. So that's the cleaned hips and all the residual waste that we get off of it. Of course, you're always going to get a little bit of fines of plastic. That's completely unavoidable when you're doing friction washing. However, I think the results do speak for themselves in this case, and this is just the dry washing or the friction washing. We also partner with companies to do complete full wet washing lines, something like a Lintner, similar to a Lintner Wash Tech that is the standard for wet washing, where we have the standard sink floats, we have friction washers. And the beauty of our setup as E-Factor 3 is we're extremely flexible in the solutions that we can provide. We're not married to one piece of technology. Of course, we would like to sell our partner's piece of machinery. But if you come to us and you say, I don't like those guys, I want to buy someone else, or this makes more sense for us, well, we'll do everything we can to work with you. And I think that flexibility is important. Because if you don't have flexibility, then you pigeonhole yourself into one kind of technology. Now, one of the last steps, depending on, again, the spec that you're going for and the industry that you're selling this into, might be a pellet mill. As we all know, agricultural film, super thin, high surface area, really light and terrible to transport. I mean, do you really want to, pack a full truck full of feathers, essentially? No, it doesn't make any sense. If you use a pellet mill or something similar, you can densify that material up to 10 times its original weight. That also makes it much more easy to feed into some kind of advanced recycling process. Just a couple years ago, we did a full 20,000-pound trial across Europe with agricultural film that was sourced here in Florida. We brought it to Moss for dry cleaning. We brought it to other companies for agglomeration. And then the client that we worked with, they sent samples to 4 different advanced recyclers, and 3 out of 4 of those found the material extremely promising. And that was, again, only with dry cleaning. And this is kind of what those, pellets look like. Unappetizing. And then once we get past that point of cleaning the material, of getting all the crap out of it, it's either advanced recycling or it's probably extrusion. So here's just an example of one of our partners in Germany, IRT. They produce a single screw extrusion system with a cutter compactor on it. So, let's say we're not going to advanced recycling. We just have the fluffy stuff and you're doing it all in-house. Well, this may be the right solution for you. And again, I think that flexibility in technology is extremely important. If we wanted to produce a more engineered pellet, something that has additives in it, where we have to add, let's say master batch, let's say fire retardants, let's say any number of talcums or calcium carbonates. We do not want to compound with a single screw extruder. It does not get enough mixing in our mind to properly homogenize the material. In that case, we work with our partner Moss out of near Linz, Austria. And they produce this recompounding line. And we call it recompounding because we can recycle and compound in one step. We don't have to first pelletize and then compound. And this is just going a little bit more into the different things that we can do. Whether it's LD or HDPE, PET. Again, flexibility and staying on our feet is always important to us because our clients keep us on our feet. As soon as we think we figured something out, then our client emails us and tells us to start all over from scratch, right? I think everybody here understands that. And here's just a quick example. We have a wash flake, we have a filler, and we add a modifier as well. And we can recompound in just one step. Again, so you don't have to create a pellet and then send it out to a toll compounder and have them do that for you. You increase the heat history of the pellet. So therefore, you've degraded your material more. With this, you can minimize that heat history and create the highest quality pellet that you can find. Last thing I'm going to go over here, I think it's the last thing. I'm not sure. Is the odor removal technology from Kreinborg. So once you've created a pellet out of ag film, another thing that they don't mention is that it smells terrible. And you've got fertilizers. Sometimes you've got compost on those fields. So if you try to make a pellet and you want to make some kind of consumer product out of it, well, I don't know about you, but I don't want the stuff in my house smelling like compost or manure, right? So we need to deodorize it in some way. Kreinborg produces an infrared drying drum. And with that infrared drying drum, we can heat that material up in a very economical way, similar to maybe a microwave or something of that nature. And as we keep it under that heat for anywhere from 20 to 40 minutes or so, we drive off a lot of those volatiles that produce that stench that nobody wants. So let's just go over that a little bit again. From the beginning, film recycling process, stage 1. We want to shred. We want to get a magnet. We want to screen out the really loose, small stuff. And then we want to wind sift it or do some kind of density separation. And we prefer wind sifting because, yeah, you can float sink the material, but then again, you're dealing with water. You're dealing with driving that moisture off, which is labor intensive, energy intensive, and just all over a pain in the ass. And then we go to secondary shredding. Now, this kind of goes into the different off-takers that you can talk to when discussing ag film. You know, chemical recycling, basic, it's been a long week, sorry. Basic mechanical recycling, or even high-grade mechanical recycling. Just depending, again, on what the client needs. If we can get away with just dry cleaning and extrusion, that's great. If the client needs a cleaner piece of material, then we would look into wet washing. And then, of course, we go into, at the bottom, like I talked about, recompounding. And this is just a few of the partners that we work with. Again, we're in the waste and plastic spaces. We got a booth here, booth number 6. And we also have a big fleet of rental machinery for this kind of processing. So we can even process a lot of the ag film, the pre-processing, we can do it in the field. With a mobile baler, we could bring a mobile shredder, mobile screen, and mobile wind sifter to do that all in the field. So thank you very much for your time. I appreciate you letting me talk at you. And I hope you guys have a great afternoon. If there's any questions, I guess.
All right, Lennart, I'm straight with you. Okay. And I can attest, I've actually gotten some of the equipment from eFactor3 for a project that we're doing in Florida. So and if we have some time at the end, I may show you some slides of some of the equipment that we've done through his shop. So our next presenter, Wolfgang, I'm going to turn it over to you. Wolfgang is going to be talking about high-efficiency melt filtration for agricultural plastic remelting. And I can assure you, in dealing with the projects that we're doing right now in Florida, you definitely need filtration. So with that, sir, it is you.
Thank you, Chief. Oh, everything is here. 100%. Yeah, good afternoon, ladies and gentlemen, here in the beautiful venue. And thanks to Eugene to organize this event. For me, it's the first time here in San Diego. And that was really a great lucky chance to talk about melt filtration, challenges, needs, and so on. I killed it.
Yeah.
No.
Push it again.
This one.
That one. Yep. There you go.
Here it is. So if we are talking about filtration, if we are talking about remelting, why I say remelting? Because we, as the provider of filtration systems, we are dealing with the melt and not with the second life application. So I say remelting. And talking about, then there are some questions are always coming up. For example, what is crucial to achieve the best pellet quality, achieve material performance? Why melt filtration overall? What are the challenges? And finally, it's important, if we are talking about pellet quality, process qualities, how to measure it. So its quality control is crucial as well, because only what you can measure, you can influence. And nowadays, it's very important to make data to knowledge. It's not necessary to reinvent the wheel every day. Yeah. My name is Wolfgang Pöessenberger. I'm an Austrian guy. My home is in Austria, 60 years old. I am 16 years in the plastics business. 2006, I started with Kraus Maffei in the injection molding, some projects in pipe extrusion and white appliances, following some years with a manufacturer of recycling extrusion systems. Then I moved to Leistritz. For a special task to do the product launch for an online rheology measurement system. And since last year in September, I'm I took over the challenge to drive the business and set up the business for my company where I'm employed in Britas recycling equipment. The Britas company is now 31 years old. Everything starts in 1993. Yeah. At that time, only the well-known filtration system like piston filters were available. So a piston filter, as a standard system, is able to deal with contamination levels up to 0.6, 0.8%. So it's not that efficient economy-wise to deal with high contaminated systems, stuff. So, and from the early days on, this system goes the way following the demands of our customers, the demands of the industry, going to higher throughputs, going down with the melt filtration, with the filter fineness. It ends up now in 2024. Nowadays we are with about 500, 550 systems all over the world. Our company structure is a group structure. We are a part of this group. The group is the Next Generation Analytics Group. And all the other group members, in addition to Britas, is Colin. Colin is very well known as a supplier of lab and pilot equipment. The Next Generation Analytics is our R&D department. And as a complementary, we are delivering slot dies for the cast film producers worldwide. We have certain locations headquartered. We are in Germany and in Austria. And very important for our customers, for our OEM partners, we are big enough to innovate with our resources of knowledge, and we are small enough to cooperate, because it's very important to understand the business of our partners, understand the business of our customers, understand the business of you, and you have to be sure that we understand ours. Yep, coming to the questions from the beginning, what is crucial to achieve consistent high quality? It's like Lennart said, you have to have in mind the whole process and where is the material coming from and what is the final second life application. In between there's a process. The process needs support, hardware, software, resources. And everything starts with the original source, the origin of material. And knowing that, and knowing my goal, I can set up the process, and it starts with the conditioning, with the preconditioning of the material. Sorting, separating, washing, wet washing, dry washing, and so on. And then it comes to the extrusion process, the technology. There's a difference if I use single screw, twin screws, or a combination. Depends on my goal. And of course, then the process parameters. What is the temperature profile I have to use? What is the pressure setup? And so on. Important as well is the screw design to achieve the screw put, to not overrun the material, to degrade it. Then the venting performance, to get rid of the final rest of moisture, to get rid of monomers, to get rid of the, let me say, easy to handle volatiles. Then, of course, as it is the, let me say, last line of defense, it's the filtration technology, the effectiveness. Fortunately, nowadays, there are some technologies available. We can use disk filters, we can use drum filters, we can use band filters at the end, a combination, for example. You can use 2 or 3 stages. And then, of course, VOC reduction. You can do the VOC reduction in downstream or maybe in the extrusion process itself using stripping agents, for example, or supercritical CO2. Then, and as well what Lennart said, if it comes to recompounding, if the necessity is to use recipes, formulas, use extenders, the use of processing aids, stabilizers, and so on. It's not possible with a single screw. You have to use a twin screw. And as well, then you have to think about the components like melt pumps. A melt pump like to have a filter to be secured. Then it comes, unfortunately nowadays it's possible, to a smart downstream equipment. Why take a sample of the material, bring it to the lab, waiting 6 hours, processing tons of material, and then the analysis said, okay, we are out of the tolerance. Why not doing all this with online measurement, online viscosity measurement, color measurement, for example? Pelletizing technology. As well, what we have to bear in mind, because if you have high-field materials, underwater pelletizing, for example, is helpful, or go to strand pelletizing. For easier usage, take a HD pelletizing system. And then, of course, if we should have a closer look in our pellets or in our sample of melt, then of course the material analysis in the lab is most recommended. Next question, why melt filtration? Melt filtration at the end, as I said, we are the last line of defense, and if something is going wrong, we as the supplier of melt filters, we are mostly the guilty ones. So, and that's why it is most of important to have the pre-processing with really high coverage on it. So, we have a variability in the input material quality. Even it's pretty good washed and dried, there is a remaining rest. There is a remaining rest of sand, there is a remaining rest of soil, there could be organic ones, there could be rubbers, whatever. Then, of course, these impurities has to be effectively removed, otherwise you find it in the pellet and it will influence your second life application. You have to reduce the equipment, the wear and the tear. At the end, it ensures a certain quality level on a high consistency level, and it's important to bear in mind that the filter fineness, the technology follows your demand. Why? Because it's a different effect. My second life application is blow film, 40 microns, 80 microns, or we are talking about thin wall pipe extrusion, thick wall pipe extrusion. Could be filter fineness is 70 or 60 microns, or I can use 300 or 400. And at the end, that you meet your targets, your quality targets, or the targets of your customer. So, in particular, to melt filtration, we have to have the possibility to remove paper, organic ones. We have to remove the abrasive contaminants like sandstones, glass, metal parts, small metal parts, and so on, as well as unmelted foreign polymers or cross-linked one. Even these things has an impact in the pellet quality. And we have to bear in mind that even if we have pretty good washing or drying, or not so good washing, drying, that you find contamination levels up to 8%. How to overcome this level. And the filter fineness, the filtration level should follow your demand, the demand of your customers or of the final application. And dealing with all these questions, we are providing some, let me say, engineered filtration systems. These series are called ABMF. ABMF stands for Automated Band Melt Filter. It starts with the standard one. The standard one is where the whole story starts 30 years ago. It's a discontinuous one for lower outputs, for easier application. Then it comes to a continuous one using 2 accumulators. The last development is a continuous one with the availability for high throughput rates. And if we are talking about plastic materials with very low viscosity, for example, PET, then you see the PET-C series as one of our last development, and as a complementary system, the common standard double piston technology, with or without backflushing. Talking about agricultural materials, talking about the polyolefins, we are providing 3 types of the automated band filter. It's the ABMFD, it's a discontinuous one. Then for continuous solutions, for example, if you are using underwater pelletizing systems or strand pelletizing systems, we have the ABMFC. And when it comes to high throughput rates and let me say higher quality levels than our big guy, the ABMF twin head. The twin head consists of 2 standard filtration systems. So as we said, it's an automatic band filter. The centerpiece of our filtration technology is a filter band. And the filter band depends on the series, is with different widths. And we are able to, let me say, go for different filter finenesses down to 40 microns. If we are talking about polyolefins, if we are talking about PET, we go down to 20 microns. So, and the standard length of such a roll is 50 meters, or we can do it customized. Always a kind of a miracle is the weaving technology. If it's the plain weave or Dutch weave or the spigata weave. For me, it's always a miracle. But this allows us to as well following customers' demand. And of course, this allows us to developing ongoing some new techniques, some new filter bands. Just an explanation about the weaving technologies. It's just for information. But of course, using different weaving technologies has an influence on the second life application. The next question comes to the filtration challenges, because who defines the filtration level? And there's one clear answer: the second life application defines the filtration level, because depends if we are talking about blown film, cast film, we are talking about injection molding, thick wall, thin wall extrusion, or something like that. What I learned since I'm with Britas talking with customers, nowadays everyone is asking, I like to have 60 microns, I like to have 40 microns, I like to have 50 microns. So means it looks that there are new milestones getting set, and such low number of microns are currently only available with filter screens. And if we are going to such low levels, then it is a must that we go for double filtration. In that case, we are working together with companies like FIMIC, companies like Ettlinger, companies like Arema, companies like Starlinger, with our OEM partners or business partners, because there is no one solution which covers all your needs, and you have to have a certain flexibility. The risks and advantages. The risk is in the usage of or in the quality of the filter band. We strictly recommend Rossi and Colombo. Always depends on your needs. The advantage is that's very positive if you have abrasive material, because you will not find wear on a filter band. And you have to be in mind always not on the filtration area, you have to be in mind the open filtration area. The open area where the melt is allowed to go through. The advantages of a band filter is, and for me it's the biggest USP, that we have an automatic renewal of the band. And this is very important, because at every time you know what is going on. There is no maintenance, there is no downtime for cleaning or replacing. You can go for high filtration fineness. You have high throughput rates. We are doing a very smart design to decrease direction changes of the melt. In the best case, we have a direct flow with the twin head. And it's very important to ensure low melt loss. But in our case, the melt loss depends on the frequency of the filtration, of the filter band change. Oh, it's the PDF. The functional principle, unfortunately, the animation is not running. It's very simple. When a certain transition point is reached, then we are closing the melt channel over here. When the melt channel is closed, then we have depressurized the filter area. Both wedges are going up and open the possibility for movement. During the melt channel is closed, the melt goes to the buffer. After 120 seconds, the screen change is done, and all the melt is distributed to the melt flow. And this is the basic principle of our filtration system. The big guy is doing different because it's a combination of two standard systems, so we are able to get rid of the buffer of the accumulators. We have a direct melt flow through the channels, and if one of the filter bands, let me say the contamination level increases the pressure to a certain transition point, we are closing the melt channel and depressurize, and so we can change the filter bands and vice versa. With this combination, this allows us really high surface, high filtration surface, and low pressure deviation. We have nearly no direction changes of the pressure and very short melt channels. The next continuous one based on the standard is the ABMF C series. The only one difference to the standard filter is we are using two accumulators, which allows us a continuous melt flow. Some examples, for example, a mid-sized standard filter in agricultural film business in combination with a single screw extruder and an HD pelletizer. Melt loss in that case is 0.9%. A smaller twin head in combination with a twin screw extruder, a melt pump, and HD pelletizing. Filter fineness 120 microns with melt loss of 0.5%. Or as well a twin head with single screw with a laser filter. And as a second stage, the twin head and the underwater pelletizing system. Filter fineness is 60 microns and melt loss is 0.5%. And melt loss at the end is money, because the melt loss you pour on the floor. You can as well go for some efficiency optimization, especially energy-wise, with thermal insulations of the cylinders, of the platens, something like that. Currently, we are as well looking, using instead of water cooling, we like to go for all cooled systems. And last but not least, the last question was, what about quality control? Quality control is important. What you not measure, you can't influence. You have the data. If you do it online, you have the data in real time. Different measurements are possible, and at the end, you can collect the data, improve the process, or whatever is of interest for you. Just some possibilities. Online viscosimeters, a common thing. The standard viscosimeters are based on shear rates. Nowadays, there are as well rheometers on the market, which are not only measuring the shear rate, they are doing as well the measurement of the elongation rate. Then, of course, to get an idea, for example, about the quality of your input material, to get an idea about the contamination, you can use some pressure filter tests, and, for example, to have good view about your pellet quality. If there are some inclusions in of gases or something like that, you can use gas control units. And of course, what that as well comes up is the usage of, let me say, color measurement systems. Yeah, thanks again for your audience. And, yep. Thank you.
Thank you, Wolfgang. Does anybody have any questions for Wolfgang? Otherwise, we're going to move right into Alex's presentation. Alex is Teipel sales manager for American Starlinger, and he's going to be talking about advancements in odor removal technology for agricultural plastics.
Thank you very much, Eugene, first and foremost, for you and your team putting this on in beautiful, sunny San Diego. It's always great to be back on the West Coast. And thank you for the introduction. As mentioned, I'm Alex Teipel, so US and Canada sales manager from Starlinger Recycling Technology. And I'll be speaking to you about advancements in odor removal technology for agricultural plastics today. A little bit of company background. The Starlinger Group has 3 different business units. We started the really forefront of woven polypropylene packaging with our textile packaging division in the 50s. And this is an interesting topic because it's actually come up quite a bit today with the amount of woven PP that's collected on farms and the super sacks. So Mr. Starlinger, the former managing director of the company, actually created the circular loom in 1971, which led to the advent of the super sack being a product that was able to be created and then, of course, used globally. So out of that came the Starlinger Recycling Technology division in the late 80s. So it really started with recycling the in-house PP tape waste that was generated from these companies. And since the early 2000s, we've really broken into the PCR world to try and reclaim hard-to-recycle plastics. So where that leads us now is being the global market leader for bottle-to-bottle recycling. We have over 250 bottle-to-bottle lines installed globally, and we're now making a heavy push into the polyolefin market as well. And we also have a third business unit called Viscotech. It's actually located quite near Wolfgang in Linz, just north of there. And they focus on PET sheet extrusion, and also they supply us with the SSPs, if you're familiar, solid state polycondensation units for our bottle-to-bottle technology. And with that, we do have a large North American presence. So we have an office located just outside of Greenville, South Carolina. That's where I'm based, along with 30 other employees. And you can see that it's called American Starlinger-Sahm, because within the Starlinger Group, we also have other associated companies. And Sahm is a German winding division that we also represent. So we have a full sales team, spare parts warehouse, and then a new trial line that's coming as well, which I'll talk about a little bit later. So by this point in the day, I'm sure you've heard many different details about what makes recycling ag plastics difficult. Of course, the variety of polymers that are in use. UV degradation is definitely a concern. Humidity levels, and of course, contamination. I think all of us have mentioned contamination and will really stress it as being a challenge to deal with this type of material, whether it's organic, dead animals, wood, paper, things of that nature. It's important that you deal with that in a way that the PCR can be reused in, let's say, a high market application. So we've really taken it on to investigate ways to get this PCR to a good end market. And I think this is a really good slide that showcases some of these contaminants. You can see that this is actually a picture, or these are pictures taken from the filter screen themselves. So you can see sand is a huge problem, wood, silicone from drip tape, metal contamination, of course, other polymers, and then paper and organics. And I'll discuss why this is difficult to deal with in a more traditional recycling process, and also the ways that we circumvent this in our process. So the solution that we've come up with is the RecoStar Dynamic CVAC with PCU+, which is quite the mouthful, as you can see. But it's really our full line solution for processing post-consumer material, whether it's rigids for high density and polypropylene, to ag film specifically, or distribution film. This is really the line that we recommend to most customers, but specifically for the agricultural market, with the addition of our PCU Plus deodorizing unit. Now, we've had the PCU technology since 2016, which is the odor reduction unit in itself, but I'll go into more details a little bit later about what's new with PCU Plus, which we just unveiled at the NPE show in March. Now, a little bit about the processing steps. So what makes us different, I'll touch on here in a little bit, but of course it's a more traditional agglomeration system. We call it the smart feeder, where material is fed directly into the agglomeration unit via a conveyor belt. And of course it's heated up via friction to get the material to the appropriate temperature to feed into the extruder. And what already makes us different is that we're using a hot air flush in this system, which is already removing some odor in the process. And this is typically already washed material, of course, so the humidity level can vary. But with this hot air flush, it's driving off some of that steam as well in the process, and then also removing some, let's say, residual or initial odor. And that's evacuated into a separate steam and dust exhaust system. And an important thing to note is that as a European machine manufacturer, we have to be very energy conscious, right? The US is of course a different market with cheaper energy needs, but as a European supplier, energy concerns are always at the forefront. So we're actually taking heat from the first extruder and recycling that in the process in the hot air flush, which we introduce in that agglomeration step. An important thing to also note is that with this setup, we do not have a degassing port in the first extruder. So we're a unique manufacturer in that we split up the first extrusion screw and the second extrusion screw, which focuses just on degassing. This ensures that the continuous filter solution of your choice, which we often recommend Fimic in this case, can continue to catch those contaminants, such as the wood, such as the organics, that will actually off-gas on the filter screen. So if you have degassing prior to the filter, you're still going to have issues downstream with inclusions in your pellet, because as that contaminant sits on the filter screen, degassing had already occurred. So that's going to be present in your pellet and is going to cause issues downstream. But with our solution, we have the CVAC degassing second extruder after the first melt filtration step. And this is the most robust degassing system on the market, and it really opens up the melt with 2 vacuum systems before and after the point of entry to drive off those VOCs. And I actually have some GC data from gas chromatography that shows the initial reduction in VOCs from just the CVAC unit itself. And then, of course, comes the pelletizer. We are now often working with other filter companies, such as Britas, on a post-filter, which actually, of course, occurs prior to pelletizing because of these more demanding, let's say, requirements to go back into blown film or blow molding, depending on the polymer type. And then we finish the whole process with the PCU, the pellet conditioning unit, which is now the PCU Plus, which I would like to introduce. So it looks a little bit different. There is some internal changes, of course, with vessel geometry, which the next slide will touch on too. But what did we add to this system? You can see O3 is listed here, which of course, if you're a chemistry nerd, which I'm unfortunately not, stands for ozone. So we're using ozone gas in this process, and ozone is widely used in different industries such as paper, water purification, and also fire restoration to remove VOCs and to remove odor. So we've introduced an ozone generator at the bottom of the pellet conditioning unit. And the way that this system works is the pellet will actually enter into the top, which this is a preheater. So each customer who gets a PCU Plus of ours will receive an oven with the unit. And this is important because you want to batch test whatever material you're running that day to see what the softening point is and what the melting point is of the polymer. And once you do that, you want to set the process conditions in the actual vessel to be 3 to 5 degrees Celsius below that softening point. And this is going to allow the contaminants, the VOCs, to actually migrate to the edge of the pellet. And this is a learning that we've applied from our knowledge in the PET bottle-to-bottle space. So we do a similar process with our SSP units under vacuum and with nitrogen. But of course, here we're using overpressure and temperature and with ozone. So when those contaminants migrate to the outside of the pellet, there's a hot air flush with the addition of the ozone gas that will then come through the bottom of the unit and actually shift the pellets around, therefore latching onto the contaminant and removing it from the system. So with the PCU Plus, we've added efficiency with temperature control. We've added extra deodorization and super cleaning capacity, and we've added an additional larger sized unit. And a little bit more on the technical details. Again, we're using that ozone process air, but a big portion is coming from the advanced vessel design and geometry on the inside of the unit that allows this to be an efficient process. So we're only using, and it depends on the process and contamination, roughly 100 grams per hour of ozone in the process, so it's not a whole lot. And with that as well, basically the ozone generator works by applying a very strong electrical charge, and the ambient air that passes through that generator will actually have ozone created because that electrical charge binds an unstable oxygen atom with O2, which is oxygen gas. And then when we're using that in the process, that ozone molecule is then splitting, where that radical is then oxidizing the material, as I mentioned before. So here's the list of capacities for the PCU Plus. Another important thing to touch on is that this is a fully Starlinger produced and Starlinger designed unit. So there are others on the market who of course use different technology, but ours is the most efficient with the lowest residence times as well. So for flexibles, we're looking at about 2 to 2.5 hours of residence time. And for rigid plastics, it's typically in the range of 4 to 5. But with these outputs, we've added the 11,500 unit, and this is 11,500 liters of capacity. So really for our 2 to 2.5 ton extrusion lines, because previously the 8,500 was the largest size, but sometimes customers would need 2 of them in line to keep up with the output. So we're always listening to customer needs and of course then evaluating future solutions on that. And this isn't, let's say, a faraway pipe dream as well. We actually have 2 of these 11,500 PCU Plus units located at a recycler in Mexico, so it is already commercialized. So what are some of the achievements that I can show? So this is a GC analysis comparing conventional pellets that were extruded on a Starlinger extruder, but with our typical degassing, so our single screw vented 40 L over D extruder without the CVAC. And you can see that the GC analysis shows quite a bit of low molecular weight compounds and some medium ones with a large spike here in the middle. Already, below here is this blue line, and that is that CVAC degassing unit that I mentioned. So this is when the pellet was pelletized right after CVAC, prior to treatment in the PCU+, and you can already see that huge reduction in VOCs, which is why that I claim that we have the best degassing on the market, because it's really the most robust. And then afterwards, you can see down below, the red line here is the results after PCU+. So really almost a flat line. And then this is an example of a GC measurement for low density film. And you can see that the total peaks in area are greatly reduced from the input to afterwards with the PCU+. So basically, with the GC screening, with that area measurement, you're taking the summation of all of the area under these peaks, and that number on the next slide is that resulting area. So that's a really good measurement and way to quantify. A good case study and customer that's been in the news lately is Ambiente. They are a Portuguese recycler. They're an interesting company because they do both agricultural plastics and also post-consumer detergent bottles and things of that nature. So they're actually using our equipment for both of those streams, of course with different process conditions and different parameters, but they're able to accomplish their goals and sell back to high-end end markets both in the EU and North Africa. And you can read, of course, Paulo's very nice statement about going after the best filtration and, of course, extrusion technology to go back into those high-end applications. And we are in California, so Silicon Valley, of course, is a big part of the state. And if any of you are familiar with the late CEO Steve Jobs, he always had one more thing at the end of his Apple presentations, and that's actually how the first iPhone was unveiled. Not that I'm saying this next innovation is to that level, but I certainly hope so. This is another interesting development from Starlinger. It's from Starlinger Viscotech, actually, so one of those other business units that I mentioned. But this is called the Visco Zero, and it is the unit located right here in the middle, after the recycling extruder and before the pelletizer and PCU+. So this is a melt phase decontamination and homogenization machine. So it doesn't have a traditional screw on the inside. It's actually a set of mixing arms. And depending, of course, on the polymer type, there's a different mixing arm design that's used. But the residence time is from 20 to 30 minutes, and it mixes the polymer together under high vacuum. So what you're doing is exposing the surface area of that polymer to the high vacuum and pulling off all of those VOCs. And the interesting part of this machine is the result on low density or linear low after a blown film trial. So we've done a lot of work with European ag film recyclers, and the results are astounding. There are no gels, no inclusions in this melt after running it through this full system of the Starlinger recycling extruder and then the Visco Zero. So the quality is really superb, and we think that this is the future in terms of processing a really great PCR regranulate from PCR film. And there's two sizes at the moment, the Visco Zero 600 and the Visco Zero 1500. And of course, that corresponds with the outputs. So the 600 is about 600 to 800 kilos per hour. And the 1500, of course, depending on material type and melt flow, is anywhere from 1100 to 1500 kilos per hour. And this solution can be sold standalone as well. So if there's an existing extrusion system and that's something of interest, then there can be discussions there too. And that's it. So any questions on this technology?
Let me ask a couple of questions. So Alex, for you, I've been in a plant where we're processing film remnants from a remnant production facility. So we had a lot of animal parts that were still part of the film. Can your system deal with something like that?
Yes, to answer that question shortly, of course, it would go through the smart feeder system, but the concern is, of course, then the carbonization in the first extruder, but then any of that contamination would be caught by a laser filter, such as Fimix, or a different solution of that nature.
Wolfgang, a question for you, sir. I've seen through the processing the amount of soil that's in agricultural film mulch. Your filtration systems, how does it deal with the amount? How often do you have to change those screens? Grab that mic right there.
Thank you. This is really not easy to answer because, as you said, it really depends on the amount.
Okay.
So it could be every 5 minutes, and of course it depends on the filter fineness. So it could be every 5 minutes, could be every 15 minutes.
And is that an automated process, or do you have to stop the system to exchange those?
No,
those
it's
screens?
fully automatic.
Okay.
It depends on differential pressure and on a transition point.
Okay.
You have not to take care about.
All right. Do we have any other questions? Yes?
Hi, I'm Leo Neal with the Ag Container Recycling Council. I have a question for Alex. So I was wondering about the test methods that you had measured with measuring the VOCs and how you measured them. Did you have different test subjects wearing different measuring devices, or just how did you measure the VOCs for real life scenarios?
Sure. So we use Headspace GC method. We use a specific machine. I believe it's Todler Metler, some brand like that. I can get the actual brand name for you at a later point.
Yeah.
But yeah, we always do a Headspace GC measurement for the VOCs.
And also, is anywhere in the United States has any of these current machines?
So like I said, the PCU Plus just came out at NPE. So in the States, not for the Plus yet, but we do have full Starlinger lines here in the United States that have the full, let's say, RecoStar Dynamic with the CVAC and the PCU. And then we also have a couple of standalone units as well.
Great. Great presentation.
Thank you.
Lennart, I got a question for you, but I think what I might want to do, Dave, can you pull up my slides real quick I can kind of give everybody an example. If you want to see a full-scale application in terms of a mobile shredder, I'm going to run through these real quick here. I don't have to tell everybody about agricultural film mulch. I think everybody in the room has dealt with this before, or at least has the facility. I've been dealing with it in the state of Florida since 1999. It's been an ongoing problem trying to figure out why this has not been sustainably recycled. And if you heard me ask the question earlier today, there's an exemption in the Florida Solid Waste Code that allows the farmers to burn in place at the end of the growing season. Several companies have come in to try to set up operations, and all of them have failed. And that main reason is because of the amount of soil contamination with it. We have a lot of piles. As I mentioned, it's being burnt in the field at the end of the growing season where they're going to grow your next set of crops, right? So we've got to find a solution for that, and that's what I'm working and have been working on, which has led to, when we talk about the soil contamination, I wanted to know, I've talked with brokers over the years of what the soil level contamination is. I've heard 25%, 30%, 50%. I wanted to know myself, so I did my own trials. And of every sample that I've done, I did 10 samples from 10 different fields, and it's always over 70% soil contamination. I've worked on kind of like Theron and Ben dealing with, pulling material out of the field. I've worked on my own equipment over the years to try to extract out, trying to figure out, well, let's leave the soil in the field where it needs to be, at the beginning. And so we've looked at rolling equipment to roll the film out of the field. I've looked at drip tape recovery, where we're extracting the film or the tape directly underneath the mounds prior to the film being pulled. And it's really, if traditional recycling isn't going to work, from my perspective, well, that leads to potentially really good options, and that is the use of the films, the plastics as alternative fuel for the cement industry, great BTU value, or using that as in advanced chemical recycling. I've done a number of different trials looking at shredding and screening 5 different types of mobile shredders, and that's what led me down the path. Well, if traditional recycling equipment won't work, what can work? And that led me down the path of the C&D industry, where you're going to look at a piece of equipment that can deal with the abrasive materials. So I've run trials with a number of different types of mobile shredders, then going into a series of different trommel screens, shaker screens. This is a trial that Hartmut in the back helped me with at E-Factor 3, Lennart's dad. We did a trial at a cement plant, and I think this is one of the EcoStar screens, isn't it, Hartmut? Yes. Okay. And that's one of the very first ones that we had tried, right? So I think this is like maybe 5 or 6 years ago that we brought in the shredder, ran it into the EcoStar screen, and then from there it went inside the plant where they were burning it. That led me down the path, all right, I want to do this in my next project. So I went to the legislature in the state of Florida and pitched the idea. I had done that for 5 years in a row, and I always got the answer no, because I had the term agricultural plastic recycling project, and I couldn't get anywhere with it. Lo and behold, we had a little thing called a hurricane called Hurricane Ian that hit South Florida. And one of my legislators said, well, you might want to change the name of your project. So I threw storm debris in it, and I got it funded. So I got $1.3 million to go after equipment that Hartmut helped me secure, and we ended up partnering up with a company that had tried to start off a recycling operation in Florida about 8 years ago, bought some equipment, was told that the equipment would handle agricultural film, and lo and behold, it didn't, right? And so they've got 50,000 tons. This whole time, they're collecting mulch film out of the fields from the farmers. No tip fee, just taking it in for free. 50,000 tons stockpiled on site that they said, well, we're not going to deal with it anymore. So they shifted over to plastic bags, right? So I kept up with them, told them of our trials. I said, I want to do the next project with you, and that's where we are right now. So we've got an M&J shredder that I got from Hartmut. I've done a series of different trials with various screening technologies. This particular screen that you see here is an aerial of one of our trommel screens that we were shredding and then going into the plant. We're using two different trommel screens right now. We've got a dry one, and then we're going into a wet one. From the wet one, it then goes inside the plant where it is shredded again, and then goes through a series of wash tanks into a dryer, then into a densifier, and then to an extruder, right? So these are some examples. This is the end product, right? It's a pelletized, that's, all right, so it's a pelletized product that is then the offtake agreement is going to Exxon in Houston, right? So pyrolysis does work, right? Despite what you hear, it does work. You wouldn't have a company like Exxon put the amount of money in it if it didn't. Processing right now, roughly about a ton an hour is the output, and that's the bottleneck for us, right? We need more equipment. The M&J shredder will shred roughly 10 tons an hour, so we've got plenty of opportunity, but we're not taking advantage of it. The plant is running one shift a day, and I think eventually they'll get to the operation where they either add more lines or add multiple shifts, because that unit is a beast. It really is. It's fun to watch. It's fun to see what it will shred, because it'll shred a lot more than plastic. And like I said, the input is Exxon. So I think, Lennart, for you, where are you all investing your time and resources in terms of trying to find other end markets for materials? Are you doing more projects around the country on either alt fuels for a cement plant or advanced recycling?
Yeah, I'd say advanced recycling is probably the most up and coming industry for this waste stream, and I think it If you're someone that's looking to convert your agricultural plastics into $1 or $2, then I think that's the most logical way to go, because you don't have to deal with quite as much cleanup on the material. You have slightly looser tolerances on the material, and I think that saves you a lot of headaches. And there's a lot of projects coming online across the Gulf Coast, in the Mid-Atlantic, across the Midwest. So,
when you talk about other projects that are going on right now, tomorrow you're going to hear some good presentations about some research that's going on. Lisa, raise your hand. Lisa DeVetter's got a grant through Washington State University to look at not only the biodegradables, but also on the recycling side. So, Kevin, raise your hand. Where's Carl? Carl in the back. Are you going to hear those two gentlemen talk about what they're doing? Kevin's on the pyrolysis side. In fact, we have a whole session tomorrow on pyrolysis, which I'm really excited about, because you're going to hear some new things that are going on in the pyrolysis, and the potential of where not just petrochemicals, that other things that are going to be taking place. And then, what, Carl? Oh, yes, and Quinn, thank you very much. I appreciate that, because that's another end market, is potentially to use, the material coming agricultural film mulch in asphalt, right? So I'm looking forward to tomorrow in some of the talks. All right, do we have any questions from the audience? Because I know we got a bar. Yes, Mark.
Sorry, I'm between you and the bar. So, Gene, one of your last few slides, and you were showing, or I guess it was when you were talking about the pounds per hour throughput. At the end of the day, is the whole process a net loser, I'm assuming, or is this after you factor in the Exxon as a offtake partner, is this all happening as a result of the grant money, or are you actually able to break even on this?
Yes, and it's beyond break even, right? I won't divulge to you what the price that Recycle Poly is getting for price per pounds, but I can tell you it's definitely a moneymaker. Again, they're getting their materials already stockpiled. We generate roughly 40,000 tons of mulch film in the state of Florida on an annual basis. In California, it's 120,000 tons. Plus. Yes, Igor. All right, so Igor just asked, so those that are listening, what is causing the bottleneck? The bottleneck is I can process 10 tons an hour with the M&J shredder. I can only internally in the plant do a ton an hour. There's the bottleneck. I need more equipment is what I need, right? Everything. I mean, it's from the washing to the densifying to the extrusion process. Yes, sir, Theron.
Tricked me. So, I mean, in your mind, is this not I mean, we're California, we don't have the water, we don't have a lot of things that you guys have the benefit of, but even where you have that, is this not a viable, is there any outlook for this product going back into mulch film itself? And I don't mind. I think advanced recycling is great. I think incineration as a alternative fuel is great. I'm just curious, your experience, is that the outlet for it?
I think it can go back into film. I heard Ben talk today. He said I wasn't listening when he made a comment earlier, but I was. I'm listening out at the desk out there, listening to the presentations. Ben made the comment about going back into a thicker film. I highly, most of the films in Florida 1.25 to 1.5. I think it ought to be 2, right, or plus, because you talk about the easing. Who here in the audience has ever pulled mulch film from the field? All right, a few of us. What a pain in the butt it is to pull that film, especially if you're doing it with a tomato plant where you got, in Florida we have stakes, right? So it's a 6-foot when you're growing cherry tomatoes. You got a 6-foot stake in the ground, in that mulch all the way down, and you start pulling it, it rips. It's a pain. So if you were to make a thicker film, and I heard Ben say it, it's easier to pull. I heard it also say something about China starting to mandate or recommend that be used in China. I highly agree with that. I think we need a thicker film, and if you went with a thicker film, it's a little bit more forgiving in terms of blowing, that you can incorporate some of this material.
What about that product? That product you're making?
The product I'm making, I don't think it can go into film. It'd have to go back into something else. And I'm sure it can. It's just a little bit forgiving with the amount. There's still some contaminants in there that Exxon can deal with. And I'm sure other pyrolysis. I'm sure you're going to hear Kevin tomorrow talk about what his research is looking at. So.
Glad to hear you were listening, Gene.
Yes.
Do you think that it would still be a winner at the Recyc Poly plant if they had to cover the inbound logistics on the material, or do you think that the fact that it's all like basically they started from scratch and oh, by the way, our factory is next to a glacier-sized hunk of plastic, that's going to help? In light of what I've seen, they wouldn't have switched over back from plastic bags if it weren't for that MJ shredder. I'm going to tell you that right now. That is the key to the entire process for what we're doing. I mean, there's others. Thron, I saw in your presentation, see, I was watching you too. You had the guillotine, right? And I think that's a great idea. I'd like to look at that as well. If you can guillotine, and perhaps we might start that process off. You guillotine it and then go into the trommel screen or shaker screen or EcoStar screen and try to help reduce that soil level. The soil level is mind-boggling when you actually see it in person. What you think, this jar of film here, is 70% by weight. And you look at it, it doesn't look like it. I can't see any soil in there, but I guarantee you if we were to take this and wash it, it's 70% by weight soil. All right, we're over time, and I want a beer, so get out of here. Thank you.